I am Arthur Francis Deban. Today we're going to be dealing with the normal error curve. In the normal error curve, if the curve is symmetrical, we say it's a Gaussian curve. But if it is non-symmetrical, we say it is a skew curve. So we have a formula which we're going to use to determine that. Okay, this is our formula, which is exponential raised to the power minus open bracket s minus s bar squared divided by 2d squared all over d, the root of 2 pi. Now, in this formula, the d here represents standard deviation. So we can call it x for standard deviation, or we call it d, as the case may be. And our x minus x bar is one of the principles or the rules which we use in attaining our standard deviation. If we want to use that principle to get our standard deviation, we can use that if we want to do that. But otherwise, we can just go straight to do what we need to do. So in the course of us solving this problem, whatever the problem will be, we must get our standard deviation in the process before we can now proceed further to get what we are doing right now. So let's see what we can do by taking a question first of all. Okay, let's take our first question. It says plot the distribution curve for the following set of data. It's 29.7, 30, 28.5, and 29.9. Let's take the set of data, which is our x. So we should plot it and find out if it is a Gaussian or a skew plot. So, for us to do that, remember, in the course of us doing this, we must also know what our standard deviation is. So if this is my x, let me have this as s squared, which will give me what I'm looking for standard deviation based on the formula which I intend to use. Okay, let's go down. Now, from here, if you see x minus x bar, that x bar is the mean, which means we must create a column for that, and we must also know what our mean is. So this is x minus x bar and x minus x bar squared. So, this and the last one is our y. We must also know, in the course of solving whatever you get here is your y. So this is the column for y. So we have that now, and let's see what we're going to get at the end of the day. Okay, first, since I'm going to know what the mean is, let me first of all add all of it. I have 29.7 plus 30 plus 28.5 plus 29.9. This is 118.1. 118.1. This column will give me my standard deviation, so let's move up there. We have 29.7 squared. I have 882. 82.09. 30 squared is 900. 28.5, 812.25, 29.9 squared, 894, 0.01. So I'm also still going to sum this. This is 3488.35. So we have to now minus our x minus the mean. So we have to know what our mean is. X bar is summation of x over n, which is 118.1 over 1234. 4, and this is equals to 118.1 divided by 4 is equals to 29.525. 29.525. Alright, let's work on our table now. This minus this, I will start 29.7 minus 29.525 is equals to 0.175. Let's square that. 0.030625. Next one. Okay, that is number 1. We're done with our first table. Now we want to know what is our standard deviation, so that if I want to substitute these variables into the formula, at least I should know what the standard deviation is. So let's take the standard deviation now to be, this is equals to the root of summation x squared minus summation s squared over n minus 1. And this is normal x squared, the summation is 3488.35. 3488.35 minus this other x, 118.1 squared divided by n, the number of degree of freedom, 1, 2, 3, 4 over 4 all over 4 minus 1, and this is equals to equals 0.69 to the nearest two decimal places. So if this is our standard deviation, then we have to start solving. We have to start dealing with the formula itself. So I will prefer to be using this side to solve for my y, because I need a table to be picking out these variables. So I'll leave the table, I wouldn't clean it. But let me write my d. My d is equal to 0.69. Whatever I need, I come down here, get it. So let me clean this now and proceed. Okay, our first y, we want to solve for our first y. We say y is equals to this. So I have my exponential raised to the power minus open bracket. In the first y, which will be this, my x minus s bar square, which is this, will be 0.03065. So I have 0.030,625. That is that. Divide by 2 times my standard deviation square, 0.69 square, will be, remember this is our standard deviation. So yeah, the d square is 0.69 squared is 0.4761. 0.4761. All over d is 0.69 times the root of 2 times 3.14 0.142, which is our, how do you call it? Our power. So permit me, I want to resolve this, because this answer here is going to be constant in all of them, and this answer too will be constant in all of them. So let me resolve this and have a fixed value. Resolve this, have a fixed value, so that will be faster. So first, 2 times 3.142 is equals to this, 6.284. Now if I root that, the root of 6.284 will give me 2 point whatever it is times this, times 0.69. I have, so the downside of the equation is now, let me call it down, capital D for the downside, is now 1.7297 for decimal places. Okay, now on this other side I've multiplied this, so now let me multiply by 2. 2 times 0.4761 will give me 0.9522. 0.9522. Alright, so with this now we can move faster. Okay, I have my exponential here, raised to power 0.03625 divided by 0.9522. Alright, all over the downside is 1.7297. I move further, exponential minus, okay, now this one will give me what? 0.030625 divided by 0.9522 is equals to 0.03216,236. Divide by this, divide by 1.7297. This gives me exponential 0.018594184. So the exponential of this will give me, take my exponential second function, exponential minus 0.018594184 is equals to 0.98. So in our first chamber for y is 0.98. So I have to start all over again. I have to clean all of this to deal with the second one. But I know this to be 2 times d squared, the value is 0.9522. All of this down, it is 1.7297. And this will be coming in subsequently, so it's going to be faster from now on. So it is that. I'm done with y or y1, as the case may be. Let's go for y2. This is exponential minus, open bracket, the second value here is 0.225625, close bracket, divide by 0.9522, all over, the downside is 1.7297. My y2 is equal to my exponential minus Alright, let me deal with it now. 0.225625 divided by 0.9522 equals to this, divide by this, divide by 1.7297 is equals to this, minus 0.136989807. My y2 will be the exponential of this. So I go to my second function exponential minus 0.1369889807 is equal to 0.87. 0.87. I come down here and write 0.87. Take it out and go again. 0.92. 0.92. So I come back here at 0.92. Okay. We're done with our table of values. We've gotten our y, our x is known. So now we have to plot the graph to know whether the graph is cosine or skew. So in so doing, I'm going to take a little part of this plot, but what I need mostly is the y column. So I'll transfer the y down here and take out all of this, then plot my graph. So if we use our graph booklet, it's going to be very different from what we're going to get here, because this is a freehand sketch to show us how it will look like when you use your graph book. So y and x, 0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1.0. Now this way we have the values falls between 28 to 29.9. So I can easily say this means all this starting from 0 to wherever I am right now. I call it, let's say, 28.5. Yeah. 28.5. 29.0, 29.5, 30.0. Anyone below, above that? The x. Okay, I have 30 as the highest. So I can stop there. So let's start. My first y1, I have 0.98. So if I take this to be my 0.98, and the other one is 29.7. 29.5, 0.6, 0.7, let's call it somewhere here. Let's call it 29.5. Let's call it 29.7 here. 29.7 down to 0.98, 0.98. The next one is 29.9 here. Okay, 29.9. Yeah, I got it. 29.9 is here to 0.92. 0.92. Oh, that's above 0.92 somewhere here. Okay, and this one was 0.98. What was that? 0.98 is up, okay, correct, to 29.7, 29.567 or somewhere here. Okay, let's give that to this. The next one was, we're confirming 30 to 0.887. This we give it here. And the other one is 28.5. 28.5, yeah, 28.5 to 0.53. 0.53. Okay, 0.53 somewhere here. Okay, that's correct. And 29.9, the last one, 29.9 somewhere here to 0.92. 0.92, which is somewhere here. So now we go, our graph will go this way. So this is the curve we get. But majorly, if you use your graph booklet, it will not be exact, it will not be in this sum. I'm only trying to show us the little, there will be deviation from the true value or the true graph which you will get if you use your graph booklet, which in due time I would like to use that to represent, to see what we get. Because sometimes, because you are using freehand, you cannot get the exact value. It could be skewed, it could be Gaussian, but from what I'm seeing right here from my examination with the freehand, it's giving me a Gaussian. But if you use your graph booklet, it could be a skew, which I would like to try that in due time to present to us. But this is what we get. So now the limit falls between this range to possibly this range, depending on how we are going to schedule it. So that is our question there. Let's take our next question. Plot a Gaussian distribution curve about the mean on normal error curve. Okay, about the mean. Let's take, and the values are, in the full question, so the following set of measurements were obtained in a laboratory experiment for the determination of the radius of a metallic ball used in Hooke's law experiment. 12.2, 12.3, 12.4, 12.7, 12.3, 12.2. These measurements were obtained using a vernier caliper. Then we should plot the Gaussian distribution about the mean or normal error curve. Okay, let's take the values now. After obtaining the values, ensure you use your graph booklet to plot it. Okay, now we go. Let's call this our X. So let's go again and see what we get. Alright, I have my X, I'll have my X squared as usual. I will have my X minus X bar X minus X bar squared I have my Y. Okay, let's begin. Okay, from here now, let's sum this up since we are going to get our mean. 4.1. So our mean, X bar, would be summation of X over N, which is 74.1 over 1, 2, 3, 4, 5, 6, which is equals to, verse 6, 12.35. 135. Now let's get this side. We have 12.2 squared, 148.84. 148.84. Square is 148.84. So we're going to sum these two because we will need it to get our standard deviation. 915.34 or 31, sorry. Now let me confirm these two guys. I have 12.7 square, 161.29, okay, and 12.3 square, 151.29. Okay, that's good. So now let's proceed. Our x minus mean. 12.2 minus 12.35 minus 0.15.15 square 0.225 225 0.0225. Yeah, 12.2 minus, let me confirm that. 12.35 is this square, 0.0225. Alright, now back to the Gaussian formula, which we're going to use to get our y. So we've gotten this, we know this. Okay, before we proceed to that, we must get our standard deviation so that we know what to do. So if this is our mean, I'm done with the mean. So let me take out the mean. I don't need it again. I need my deviation, standard deviation, the down part and the other part. So let me start. I have y is equals to exponential minus x bar square divided by 2d square all over d root 2 pi. From the first side of it, I have my exponential, this is y1, minus this, which is x minus s bar square, for this is 0.0225 divided by 2 times the d. I've not calculated my standard deviation. Pardon me. Alright, I'll leave it here. Let me do my standard deviation. I call it x, which is the root of s squared minus s squared over n all over n minus 1. And which is the summation, the summation of s squared is 915.31. 915.31 minus the normal x, summation 74.1 square over n, 1, 2, 3, 4, 5, 6, which is 6, all over 6 minus 1, 6 minus 1. And this is equals to the root. And now the root of 0.035, which is equals to 0.19. So that's our standard deviation, or 0.20, 0.19 or 0.20. So if my SD, my standard deviation is 0.19, I will have to substitute it into the formula. Wait a minute, later man. 0.19, my D here is 0.19. That's my deviation, standard deviation. So let me put it down. Okay. I have this 2 times d square, which is 0.19 square, all over 0.19, the root of 2 times 3.142. Okay, let us evaluate it as usual and put the variables down. Here, my down part is 0.4763. Okay, now let me find out the upper side here. 0.19, which is the standard deviation square, 0.19 square is 0.0361 times 2. Times 2 is 0.0722. The other part is 0.0722. So, I can now proceed further to make it faster now. This is equals to my exponential y1 minus this divided by, which is 0.0225 divided by the other side, which is 0.0722. All over the downside, capital D, 0.4763. This is equal to exponential minus, let's see what we get, 0.0225 divided by 0.0722 is equal to this, divided by 0.4763. That is equal to 0.65428 1648. This is equal to that exponential minus 0.65428164 is equal to 0.52. 0.52. So here I have 0.52. Move further. Zero 0.02. That's down 0.0. So this value is an outlier. This one, if the proper exhibition were to be carried, it's an outlier which is B that was supposed to be omitted in the process. But we are concerned only in the Gaussian. So this makes it obsolete. So this value can be inclusive because it's way too deep. Because of the error in it is more compared to the others. So permit me to take this out. So if this is our true result, which we've gotten, then we can plot this and see what we get. Alright. So we'll do like we did before, a little exhibition of what we expect it to be, but I will employ you to use your number graph booklet to plot this. So here is 0.9 as the highest. So let's take 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1.0. This is 1. I have 12.4. as the highest. So after whatever it is here, I call this my 12.1, 12.2, 12.3, 12.4, 12.5. Let's see our rough estimate of the graph. When it's 12.3, it's 0.52. 12.3, 0.5. 0.52, somewhere there. So this 12.3. I just did that. Oh, that one was 12.2. Sorry. That's 12.2. So in 12.3, 0.93. What is it? 12.4, 0.93. Now 12.3, 0.93. We've done that. The last one is 12.2. Am I right? Then 0.52. Yes, 0.52 again. So this is what we have. Everything still falls the same. I haven't gotten these two. The first one is 12.2, which is this, 0.52, 12.3, 0.93, 12.4, 0.9, 12.3 backward again. We have 0.93, so it still fits, and 12.2 the same. So I think this is more of a Gaussian curve than skew. So in the other one, I think it is because of, how do you call it? We did not use a graph. From what we should be expecting would have been a skew. This is more concise in the form of giving us what the Gaussian, because it did not give us anything as maybe here, maybe I haven't come down here, we move. That is our Gaussian. The other one has more possibility or probability of giving us that because of the numerous variables and not aligned in that sense. But when we plot it, I should bring it up again so I will be able to see. And you can take that as an assignment to look into it by plotting it. And you can comment in the comment section what is your observation after plotting it using your graph booklet. So I'll be able to notify the differences. So aside this is how we plot our error curve. Thank you. See you some other time.